All right, hello everyone. So we've just got a little bit to kind of finish up on this example. So remember from our convenient sample of Stat 113 students, we had calculated a 95% confidence interval for the proportion of all students, all SLU students with a Twitter account. So we want to just talk about whether we can do that, and if we can, what extra assumption we're making about SLU students and about students who choose to take Stat 113. And so the first question on here is, does our confidence interval cover the true parameter of interest, the proportion of all SLU students who have a Twitter? Before, when we had a census, like with the pet example, we were actually able to kind of check this out. Now that we're in a more realistic setting, we don't know anymore. All we know is that 95% of all confidence intervals will, but we don't know if ours is one of the 95% that does, or one of the 5% that doesn't cover the proportion. All right, so now that we're in this more applied setting, we're not taking millions and millions of samples repeatedly because that's obviously kind of unrealistic. So we don't really know if ours is one of the 95% that covers because we don't have access to our entire population. And so the last three questions have to do with whether our sample is representative of SLU students or not. And so take a second to think about what type of sample the Stat 113 survey is. And so we've talked about this a few times in that this is a convenient sample. So if I'm the one collecting the data on it, then it's easiest for me to get data from the class than it is to randomly select SLU students. And so now we just want to think about if there's an argument for whether we can make this confidence interval if we're interested in all SLU students as being our population of interest. And we could maybe make this argument, but the extra assumption we need to make, so we need to assume that choosing to take Stat 113 is not associated with having a Twitter. That may or may not be true. So it might be that, Stat 113 has a lot of, I guess we'll say econ majors, and maybe econ majors are more likely to have a Twitter than non-econ majors are. Or Stat 113 has a lot of first year and sophomore students, and so maybe, I don't know, people don't tend to make a Twitter until their junior year or whatever. So this is just an extra assumption that you have to make that we have no real way of testing, at least with the data that we've collected. So would we be able to use all college students as our population of interest instead of all SLU students? So this is even more questionable. Students at other universities could be really different as a whole. Maybe more or less likely to have a Twitter than students at SLU. And so if we're extending this conclusion to all college students, that's a much bigger assumption that I would probably lean away from making in this example. Would we be able to use all adults as our population of interest? This is, I wrote probably not / I guess definitely not. Um, it'd be hard to argue that SLU students are representative of all adults when it comes to the characteristic of having a Twitter. So they're probably more likely than adults in general. So SLU students are not representative of adults for this characteristic of having a Twitter. All right, they might be representative of adults for different characteristics, like I guess height maybe. You could make an argument that SLU students would be representative of all adults, but that's kind of a case-by-case basis where we have to kind of use our logical reasoning and our logical intuition about whether having this Twitter account would be representative um, for all adults, and it's probably not. Okay, so this is kind of bringing stuff back way from week one, so it's still relevant now, which is pretty cool. As always, let me know if you have any questions. We've wrapped up confidence intervals, and next time we'll start talking about hypothesis tests.